The learning objectives of this section are to understand the plotting principles, to be able to plot radar targets and calculate their course, speed, CPA and TCPA, to understand the effect of course and/or speed change. Even though the introduction of True Motion and ARPA have reduced the necessity for manual plotting skill, it's still very important to understand the principles of plotting and maintain some skill in manual plotting technique. Plotting has two main purposes. It can show whether danger of collision exists, how close we will pass the target, and how much time there is left before this will take place. Approximate determination of the course and speed of the other vessel, so that sensible avoiding action can be taken when needed. There are many different methods of manual plotting. One can be as good as another. The important thing is to fully master and feel comfortable with the method used. Theoretically, plotting should be a continuous process, but in practice, this can be impractical, not to say impossible. In practical manual plotting, a given time interval is used, for example, 3 or 6 minutes. Regardless of how short a time interval is selected, it is always the target's earlier movement which is plotted, that is, the target's history. It is important always to remember that radar system, however advanced, can only provide historic information or prediction of future movements based on historical information. Manual plotting in connection to radar means to mark one or more echoes within a specific time interval, and thus decide the target's movement in relation to own ship. The objective of plotting is to obtain the clearest possible picture of the situation. It is important to fully understand the meaning of target aspect. Aspect is measured from dead ahead to 180 degrees on either side of the ship. The aspect is defined as the angle of view. However, in connection with plotting, we will use the term calculated aspect in order to distinguish between the two. It can be defined as the angle between target ships heading and bearing to own ship, as seen from the target ship. In connection with plotting and use of radar and ARPA, we had better define what we receive from these systems as calculated aspect. Relative speed is defined as the target speed relative to own ship, as deduced from a number of measurements of its range and bearing on the radar, expressed as an angular distance from own ship's heading. High relative speed makes plotting easy. Little or no relative speed makes accurate plotting difficult. On the other hand, high relative speed means high danger, while little or no relative speed means little or no danger. Course and speed triangle is the triangle obtained by plotting own ship's course and speed and a target course and speed, starting from the same point. The third side of the triangle provides the relative movement direction. Knowledge of the speed triangle is essential for understanding the principles used in plotting. When planning and avoiding action, the navigator should try to change the plotting triangle in such a way that he gets the desired CPA. The side WO, way of own ship, which represents his own ship's motions, is the only one to have direct control over both in length and direction. The side OA will then change length or direction or both. The only side the navigator cannot do anything about is WA, way of another ship, which represents the other ship's true motion. It might be a good idea to put arrows on the sides of the triangle to indicate directions. Remember that the arrows on WO and WA shall always be aimed away from W. On OA, the arrow should aim from O to A. Heading is defined as the direction in which the bow of a vessel is pointing, expressed as an angular distance from north. A relative bearing is a bearing taken with one's own ship's longitudinal axis as a reference. If the relative bearing of an approaching target remains the same over time, collision danger is observed. A true bearing is a bearing taken with geographic north as reference. On merchant ships, true bearings are mainly used for position fixing. The bearing is defined as the direction of one terrestrial point from another, expressed as an angular distance from north. On a ship, bearings can be relative or true. In connection with traffic surveillance, relative bearings are often used. Closest point of approach, CPA, is defined as the shortest distance between own ship and a target, measured from own ship to the closest point on the echo line. CPA must not be mixed with the point where the target crosses own ship heading, often referred to as BCP, bow crossing position or point. Time to closest point of approach, TCPA, is the time estimated as measured along the echo line from its present position to the closest point of approach. Plotting on board can be done on special reflection plotter that can be placed on top of the PPI. Another possibility is to use special plotting sheets with spider web diagrams, or you may use any sheet of paper. Plotting can be done with head up or north up. However, regardless of selected radar presentation, it is advantageous to plot with north up. In the following plotting examples, peripheral plotting based on information from a conventional relative motion radar is utilised. In this first example, plotting with head up will be explained. Plotting example number 1. Own ship is stationary, 0 speed. On heading 000 degrees. An echo is observed in bearing 040 degrees at range 4 nautical miles. 6 minutes later, the same echo is observed in bearing 030 degrees, range 3 nautical miles. We like to calculate the target's course, speed, CPA and TCPA. In this example, the course and the echo line are the same, since own ship is immobile. The target course is obtained by parallel shifting of the echo line through own ship centre and reading the course from the scale, in this case 246 degrees. The target speed is obtained by measuring the distance between O and A, which in this case is 1.5 nautical miles in 6 minutes. That is, target speed is plotted to 15 knots. Target CPA is obtained by measuring the distance from own ship to the closest point on the echo line, which is 1.6 nautical miles. Target TCPA is obtained by measuring the distance from A to CPA, which is 2.5 nautical miles, which corresponds to 10 minutes. In this plotting example, own ship's head up is used as reference. Use the following parameters for plotting. Own ship speed, 19 knots. Own ship's true course is 087 degrees. Time, 00 minutes. Echo in relative bearing, starboard, 035 degrees. 7.7 nautical miles. Time, 06 minutes. Echo in relative bearing, starboard, 032 degrees. 5.4 nautical miles. Plot the observations and call the first observation O and the last A. Draw the relative course line and extend this beyond the centre of the plot C. The relative course line clearly shows that the bearing is gradually drawing ahead and that the range is decreasing. CPA in P will be 0.8 nautical miles to port. By marking off the relative distance, OA, on the projective relative track, you can estimate the target's position at 12 minutes, 18 minutes, and so on, and that TCPA is at 20. Since CPA is small, plotting must continue until the situation is cleared. From O, draw the own ship's reciprocal course, here 180, and mark the distance travelled by own ship in 6 minutes. That is 1.9 nautical miles from O, and you get point W. Connect W with A, in this example extended to S. The target's true course equals the own ship's true course plus the direction of WA on the plot or course, which equals 087 plus 278, which equals 005 degrees. The target's true speed is 10 times section WA, which is equal to 10 times 1.5, which equals to 15 knots. You plan an avoiding action, and your aim is that the target's relative course should have its point of contact on the 2 nautical mile range ring, that is, CPA 2 nautical miles. However, the plotting will take some time, so you plan for a change of course or speed to take place in a couple of minutes' time. In this example, the plan is to make an alteration at time 09. Draw a line from 09 minutes to the 2 nm circle at P1. This is the desired new relative course for the target. Draw a line parallel to 09 minutes, P1, through 06 minutes, A, and backwards. Take a pair of dividers with one point in W and your own side, WO, as radius, and draw the arc from O to the right. Mark the position where the circle intersects the dashed line with X. Your new course is the arrow from W to X. Change course starboard to new course 87 plus 30, which equals 117 degrees. If a change of speed is preferred, the new speed, as an alternative to turning starboard, can be achieved as shown on the plotting diagram. A change in speed is represented by the short part new speed from W to the new speed mark. If your own speed from time 09 is reduced to 11 knots, the target will pass with a CPA of 2 nautical miles on your port bow. A disadvantage with head-up plotting is that since we plot starboard angles, the target echo will jump to a new position on the plot if your own ship changes course. This means that you have to start a completely new plot. The target echo jumps from A1 to A2 when you turn 30 degrees to starboard at 09 minutes. When plotting north up, you plot bearings, and no calculation is required before the radar bearings can be marked on the plotting sheet. Another advantage of the stabilised radar presentation is the change of own ship course will not change target positions on the radar screen. The arrow on the graded circle indicates the own ship's course, and the example is the same as used for head-up plotting. True plotting has the advantage that it gives a natural and easily understood picture of the course of events. True plotting can be done directly in the chart if the scale is large enough to give a clear picture. Draw your ship's projected track on the chart, and on that track mark the ship's position at regular intervals. Own ship's course is 10 degrees, speed 8 knots. The following observations are made. Time 0100, bearing 065 degrees. Range 7.9 nautical miles. Time 0103. Bearing 064.5 degrees. Range 7.2 nautical miles. Time 0106. Bearing 064 degrees. Range 6.5 nautical miles. At time 0100, own ship's position is C, and at 0106, the position is C1. The points W and A are then connected with a line to form a track. This track shows that the true course of the target was 285 degrees. The distance the target travelled in 6 minutes was 1.2 nautical miles, making its true speed 12 knots. In a relative motion plot, the true motion of the target is plotted relative to own ship, which is considered as a fixed reference point. That is, the motion is plotted as it appears on a relative motion radar display. True plotting has the advantage that it gives a natural and easily understood picture of the course of events, and if required, true plotting can be done directly on the chart. Although true plotting gives a good overview, calculating accurate CPA and TCPA is a little cumbersome. Regardless of the selected plotting method, plotting must be done with high accuracy and great care if it is to be of any value. Therefore, too much traffic accurate plotting by hand can be impossible simply because it's too time-consuming. This situation has been known to navigators for many years, and after thousands of unnecessary collisions with loss of many lives, IMO have at last succeeded in making automatic radar plotting systems, ARPA, compulsory on all ships above 10,000 tons. This is a big step in making traffic surveillance by radar and a reduced visibility much safer. There are many possible sources of error in manual plotting. Here are the most important ones: bearing error, distance error, error in timing between plots, error in speed, gyro error, relative speed, manoeuvring of own vessel, unstable steering, yawing, etc. Even small errors in one or several of these parameters can cause large and dangerous errors in the plot calculations. Always check these parameters as thoroughly as possible in order to reduce the possibilities for nasty surprises during manual plotting work. The usual method of deciding whether a collision danger is present is by taking several bearings. This is time-consuming, and it requires that many bearings have to be taken. A dangerous situation can quickly emerge by taking a few inaccurate bearings from a comparatively long distance, and then forgetting the target if the CPA is considered large enough. In this example, an echo is plotted bearing 030 degrees, range 8 nautical miles, P1. The target's correct bearing is 030.5 degrees, V1. The next echo bearing is observed to 031 degrees, range 7 nautical miles, P2. Correct bearing is now 030 degrees, V2. The calculated CPA is 1.1 nautical miles to starboard and astern of own ship. As the correct CPA is only 0.4 nautical miles to port, with crossing just ahead of own ship. If this situation is allowed to develop, a very dangerous situation can soon occur. An error in distance measurement, as in bearing error, can produce grave results when judging the traffic situation. For example, an echo bearing is taken at 030 degrees, at range 7.7 nautical miles, while the target's actual bearing is 030 degrees, at range 8 nautical miles. The next bearing of the target is taken at 031 degrees, at range 7.0 nautical miles, while actual range is now 6.9 nautical miles. The solid line through V1 and V2 indicates correct passing distance, which is a CPA of 0.8 nautical miles. The broken line through P1 and P2 indicates the calculated passing distance, which indicates a CPA of 1.1 nautical miles. A timing error between two plots will result in calculation of incorrect target course, speed and time to CPA. In this example, an echo is plotted in position 030 degrees, at range 8 nautical miles. Own ship's course is 000 degrees, speed at 15 knots. 8 minutes later, the same echo is plotted at 030 degrees, range 7 nautical miles. The operator uses 6 minutes in his calculation. That is, he has a 2-minute error in his timing. 2 minutes incorrect timing equals 0.5 nautical miles, sailed distance at 15 knots speed. Target's calculated aspect, TCPA, and course will thus be incorrect. First, a plot based on correct data, X1 to P2. The solid line indicates the result with a calculated target course of 320 degrees. The broken line indicates the result of the incorrect plot, X2 to P2, with a calculated course of 338 degrees. Error in calculated target course is 18 degrees. A timing error does not affect calculated CPA. An error in speed causes incorrect calculation in the same manner as error in timing. When we speak of error in speed in connection with plotting, we must first be aware of what we wish to obtain by plotting. The normal objective of plotting on board a merchant vessel is to obtain the best possible view of the movement of other vessels, including calculated target aspect. Errors in speed of 1 knot or more can cause large errors in other ships' calculated aspect. However, we must remember that in all plotting where we wish a picture of the aspect, own vessel speed through the water must be utilised. Never make corrections due to current or drift. Speed taken from a Doppler log, which provides speed over ground, in water with strong current or drift, is not only unusable but can be dangerous if the navigator is not fully aware of the effects. In case the gyro course has an error, all bearings will have the corresponding error. The gyro course should therefore be corrected for gyro error before it's used in connection with plotting. A target with very low speed, relative or true, will make exact plotting of the target course and speed almost impossible. To perform manual plotting quickly and accurately requires a lot of practice, and few merchant navigators today pose this skill. With ARPA, the practical skill of plotting is reduced, while understanding the principles and limitations of plotting remain just as important as ever before in the history of radar. Other factors which may affect manual plotting, and which can make manual plotting difficult or almost impossible: unstable steering, manoeuvring of own ship, the technical exactness of the equipment, rough weather conditions, target relative speed, the navigator's experience and lack of plotting practice. VHF communication is a way to make one's intentions clear to another vessel, and to arrive at an unambiguous decision about avoiding tactics. It can also be used for broadcasting a general information report to ships in the vicinity. Such a report could state the time, position, course, speed, and manoeuvres to be carried out. Use of VHF is not explicitly advocated in the rules, but implicitly its use is recommended. English is the conventional language for use on sea and in air navigation, but knowledge of the phonetic alphabet is essential for all nationalities. Studying of IMO's standard marine navigational vocabulary should be a good start to improving one's maritime communication skills. The procedure of transmitting a VHF message should be in a form which is simple, concise, and has a logical sequence. The message itself should be brief but definite, as one wants to transmit using a minimum amount of time. Here are 3 basic steps to remember: identification, own ship name, call sign, type. Ascertainment of movements and intentions, time, position, course, speed, etc. Disengagement, indicating both vessels have recognised the action completed. Sea Speak is the official maritime language initiated by Captain F.F. Weeks and later adapted by IMO. More than 1,000 persons from 26 maritime nations participated in the development of Sea Speak. Sea Speak messages are formed entirely of words from the English language and consist of vocabulary of General English, words in general maritime use, and words in specialised maritime use. The central principle of C-Speak is that the receiver should be alerted to the type of message that follows at the very beginning of the message. This aim is achieved by the use of message markers. C-Speak uses the following message markers. Question: indicates that the following message is of interrogative character. Answer: indicates that the following message is the reply to previous question. Request: indicates that the contents of the following message is asking for action from others with respect to the ship. Information: indicates that the following message is restricted to observed facts. Intention: indicates that the following message informs others about immediate actions intended to be taken. Warning: indicates that the following message informs other traffic participants about danger. Advice: indicates that the following message implies the intention of the sender to influence the recipient by a recommendation. Instruction: indicates that the following message implies the intention of the sender to influence the recipient by regulation.